Welcome to the lesson number 2, Understanding Ratios. Before we begin, let us briefly go through our objectives. We have to understand parts and whole. We also have to establish a relation between them. Next, we have to establish relation between parts of the whole. We shall also analyze systems and see how they are composed of variables and constants. As the name suggests, variables have changing values and constants do not change. We shall also study ratios and rates. For example, a ratio between oranges and apples. We have some apples and some oranges. Let's count them. We have 7 oranges and 6 apples. So the ratio between oranges and apples is 7:6. Let's do another example. This time the ratio is between the sides of a triangle. The ratio is written as A ratio B ratio C. So ratios are mathematical relations that are established between quantities that are in the same units. In the case of the triangle, the quantities were all in centimeters, and in apple and oranges, they were simply in numbers. Let us now look at rates and see how they are different from ratios. Rates are used when we have to establish a mathematical comparison between two quantities that are not measured in the same units. They have different units. For instance, two quantities could be distance traveled by a car in a given amount of time. Let us take this example. We have a car moving towards the right with a certain speed. It has to cover distance d in meters, and we are measuring the time in which this distance is being covered. So in this system we have two variables, distance and time, and we are going to find the rate with which distance changes with respect to time. This is where rates come in handy. So we have two quantities. Number one is mass, we represent it by m, and the other is time with t. In the first second, the car travels 5 meters, and so on. 10 meters in 2 seconds, 15 meters in 3 seconds. Let us find the rate at which the distance is changing with respect to time. We can establish 3 ratios for the 3 seconds. 15 meters in 3, 10 meters in 2, and 5 meters in 1. After simplifying these ratios, we get the same ratio of 5:1, which is the rate at which the car is traveling. We can also find that by dividing m by t, which is 15 by 3 gives us 5 meters per second. Let us revise how ratios are different from rates. Ratios are used for the comparison of parts of a whole, or in other words, they are used to compare quantities with same units. On the other hand, rates are used for the comparison of how one variable of a system, for example mass, time, temperature, or pressure, changes the other variables. Now let us compare parts to whole. Let's relate a part with the whole. In this case, one of the parts is colored red as to differentiate it from the rest of the whole. The part ratio whole is represented in the picture form. To start with, we can see that the part is 4 times smaller than the whole, which means that the whole is 4 times bigger as part. The ratio becomes 1:4. We can also write it as part by whole, which gives us 1/4, which is a fraction. We can see how the concept of ratios is related to fractions. Let us now relate one part of the whole to another part. One of the part is colored red, and we shall color the other part as green to differentiate. We can already see how the green part is bigger than the red part. But how many times is it bigger? Let us find out. Out of 4 pieces, the green occupies 3, so it is 3 times as big as the red. The ratio of red to green would be 1:3. It can also be written as red by green. That gives us 1/3. The important lesson here is that comparing a part with a whole gives us a fraction. While comparing one part to another part gives us a ratio between these two parts. To practice the concept that we just learned, find a relation between the red part and the whole and the green part and the whole. Also find a relation between the red and the green part. In this next example, people studying in a university have been divided into groupings based on gender, ethnicity, and the subject they study. We have to find out ratios between some of these groups. In our first example, we are comparing white American people to Asian Americans. We can see that 12 out of every 25 people are white, and 11 out of every 50 people are Asian American. So what's the ratio between them? Is it 12:11? No, it certainly is not. That is because the denominators of both the fractions are not the same. Multiplying and dividing by 2 gives us 24/50, ratio 11/50. We can now cancel out the 50s on both sides of the ratio. That gives us 24:11, which is the correct ratio between white Americans and Asian Americans. Try the rest of the ratios on your own. Pause the video now. We have now achieved the first objective of our lesson, that is understand parts and whole. Let's move on to the next one. Understanding variables of a system. We have a system of mass suspended from a spring. The mass suspended from the spring changes its length. To understand how much the spring extends with a certain amount of mass, we shall use a scale. However, before that, let us revise what are the variables in this system. The first one is obvious. Since mass can take many values, it is one of the variables. What is the second variable? The second variable is the extension that occurs in the string. the extension changes with changes in mass. Let us see how different masses affect the extension. For a 50-gram mass, we have an extension of only 8 centimeters. For a 100-gram mass, we have an extension of 16 centimeters. And for 250 grams mass, we have an extension of 40 centimeters. Let's write that down. 50 grams gives 8 centimeters, 100 grams gave 16 centimeters, and 250 grams extended the spring by 40 centimeters. Do we see a relation there? Let us find the rate at which extension varied with mass. Do you see a rate here? Let us find out. Mass by extension, or mass ratio extension, m ratio x, or m by x. In the first case, we had 50 grams compared to 8 centimeters. That gives us 25 by 4 gram per centimeter, or 25 by 4 gram per centimeter. In the second case, we had 100 grams by 16 centimeters. That also eventually gives us 25 by 4 grams per centimeters. In the last case, we had 250 grams by 40 centimeters, and it also gives us 25 by 4 grams per centimeter. You can see that the rate is same. Let's look at another system having two variables, distance and time. A man walks to the right for 5 seconds, and we shall record his motion and stop it at every second to analyze it. In the first second, the man has traveled 2 meters. In the second second, he has traveled 4 meters, and so on. In the fourth second, he has traveled 8 meters and 10 meters in 5 seconds. There are two variables in this system: distance d and the time in which that distance is covered. Let us find the relation between distance and time. The body covers 2 meters in 1 second, 4 in 2 seconds, 6 in 3 seconds, 8 in 4, and 10 meters in 5 seconds. What is the rate of distance to time? Pause the video now and find that out. We have achieved the second objective of our lesson. Let's move on to the next one. A ratio is a comparison of numbers in definite order. They are expressed in the same units and are called terms of the ratio. A ratio can be represented in the forms of A ratio B, A by B, and A to B. In the example given below in the box, we have 12 girls and 8 boys on a team. How do we represent that ratio? The first way is girls ratio boys. Second, girls by boys. And third, girls to boys. There are 12 girls and 8 boys. The three forms of ratios are given as 12 ratio 8, 12 by 8, and 12 to 8. Some ratios can be simplified. In this case, these ratios can be simplified as 3 ratio 2. To practice this skill, pause the video and find the ratio between the length and the width of rectangles A and B. We have achieved the last two objectives of the lesson as well. Thank you for watching.